Righty. And good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, so today we are going to wrap up the chapter. We're going to take a second look at section 5.8. The assignment tonight is 5.8 part 2 along with a chapter review. Tomorrow we'll spend class time reviewing for the chapter 5 test, which will be on Friday. Again, a reminder, there will be no class meeting on Friday. You will just take your test. Okay, so we have some requests from section 5.8 part 1. So this is problem number 9. It says divide the polynomial by the monomial. So we have b squared plus b cubed minus b to the 4th power, all divided by b to the 4th power. So when we have a polynomial divided by a monomial, we do the following. We split it up. We take each term in the numerator and divide it by the term that is the denominator. So then it would look like this. Then we go back and reduce each separate fraction. Keep in mind, we want our final answer to have no negative exponents. So b to the 2nd power divided by b to the 4th power would be b to the 2 minus 4 power, which is b to the negative 2 power, which is 1 over b squared. Plus b cubed divided by b to the 4th is b to the 3 minus 4, which is b to the negative 1, which is 1 over b to the 1. Minus b to the 4th over b to the 4th is b to the 4 minus 4, which is b to the 0, which is 1. The only thing that I would change here is we don't need the implied 1 exponent there. So we get 1 over b squared plus 1 over b minus 1. Any questions about this problem before we go on? Okay, continuing in 5.8 part 1. This is problem number 10. Divide the polynomial by the monomial. Simplify your answer completely. So very similar to the one we just did. 40 b to the 10th power plus 8b to the 6th power. Oops. See if we can write that a little better. Minus 16b to the 4th power, the whole thing divided by 8b squared. So dividing a polynomial by a monomial, we take each term in the numerator and divide it by the term that is the denominator. Then we go back and reduce each fraction separately. 40 over 8 is 5 over 1. B to the 10th over b to the 2nd is b to the 8th power. So we get 5b to the 8th power. Okay. 8 over 8 reduces to 1 over 1. B to the 6th over b to the 2nd is b to the 4th power. So we get plus 1b to the 4th power all over 1, which again, we don't need to write the implied ones. And then finally, 16 over 8 is 2 over 1. B to the 4th over b squared is b to the 2 power. So minus 2b squared. So there's the final answer on that one. Any questions there before we go on? Okay, finally, 5.8 part 1 number 16. It says perform the division, and we have x plus 2 divided into 3x plus 2x squared minus 2. Now, there's something wrong with this problem, and that is that inside the dividend is not in descending powers or standard form. So the first thing we do is we would rewrite it. And inside we'd have 2x squared plus 3x minus 2. Then we'd carry on from there. We're going to divide the leading term inside by the leading term outside. 2x squared divided by x is 2x, which goes up here. 2x times the divisor x plus 2 becomes 2x squared plus 4x, which we write over here. Then we draw a line. We subtract it from what's up above. We change subtraction to addition of the opposite, changing the sign of each term inside the parentheses. 2x squared plus negative 2x squared is 0. 3x plus negative 4x is negative x. Bring down the next term, minus 2. Start the process over. Divide the leading term inside by the leading term outside. Negative x divided by x is negative 1. So we write minus 1 up there. We take that times the divisor, negative x minus 2. We write that up there. Subtract that quantity from what's up above. Change it to addition of the opposite. Negative x plus x is 0. Negative 2 plus 2 is 0. So our final answer is 2x minus 1. All righty, that was all the questions that people emailed me. Are there any other questions from anybody before we go on? Okay, so we're going to take a look at section 5.8, part 2. The first thing I want to emphasize is just like the problem we just did, and that is the idea that something needs to be in standard form or descending powers of the variable. So let's take this example. We have 3 plus 11x plus 10x squared divided by 5x plus 3. So outside, the divisor would be 5x plus 3. Inside the dividend, we're going to take this polynomial and rewrite it in descending powers. 10x squared plus 11x plus 3. Okay, now we'll proceed. We're going to divide the leading term inside by the leading term outside. 10x squared divided by 5x is 2x. Put that in the x column. Then we take 2x times 5x plus 3, which is 10x squared plus 6x. 10x squared plus 6x. We're going to subtract that quantity from what's up above, but we're going to change it to addition of the opposite. 10x squared plus negative 10x squared is 0. 11x plus negative 6x is 5x. Bring down the next term. Take the leading term inside divided by the leading term outside. 5x divided by 5x is 1. So we get plus 1. 1 times 5x plus 3 is 5x plus 3, which we put there. Subtract that from what's up above. Change it to addition of the opposite. 5x plus negative 5x is 0. 3 plus negative 3 is 0. So the answer, 2x plus 1. Any questions about that problem? All right. I'm assuming that you're taking notes. If you aren't, well, you should be. What I'd like you to do is I'd like you to write down in digits the number 605. Okay, I'd like you to write down the number 605. I'll give you a second to do that. So here is the number 605, correct? No, it's not correct. What's wrong with it? Nobody's going to talk to me today. Fine. Okay. It looks like the number 65. Well, how about if I wrote it like this? 605. Would that be okay? No, that looks like what? 6 and then 5. It's kind of like, what's going on there? What do? 600, 0 tens, 5 ones. Now, when I say 605, I don't say that there's 0 tens, but I haven't listed anything in the tens column. I haven't said anything. So we put a 0 there as a placeholder for the tens column so that we know that the 6 is in the hundreds column and the 5 is in the ones column. Okay, what does that have to do with anything? Well, let's take a look at this problem. A squared minus 25 divided by a plus 5. Okay, so let's use the long division of polynomials process of doing this problem. So outside we'd have a plus 5. Inside we've got a squared minus 25. Inside the polynomial is in descending powers. Outside the polynomial is in descending powers. So we're going to take the leading term inside divided by the leading term outside. A squared divided by a is a. Well, let's just put that up here somewhere. And then we've got a times a plus 5, which is a squared plus 5a. A squared plus 5a. Subtract that quantity from above, change it to addition of the opposite. A squared plus negative a squared. Oh, we have a problem here because these aren't like terms, are they? They don't line up. So what we're going to do to fix this is we're going to go back. Let's see, was it plus 5? And we're going to rewrite it so that we fill in the missing power of a. In this case, a to the first degree is missing. So I'm going to put in a 0a. 0a doesn't have a value other than just 0. So I haven't changed the value of the polynomial, but I've put a placeholder in the a to the first degree column. Now let's go back and do the problem again. Leading term inside divided by leading term outside. So a goes up there. A times a plus 5, a squared plus 5a, a squared plus 5a. Subtract that quantity from what's up above, change it to addition of the opposite. A squared plus negative a squared is 0. 0a plus negative 5a is negative 5a. Bring down the next term and start all over. Leading term inside divided by leading term outside. Negative 5a divided by a is negative 5, so minus 5 goes there. Okay, minus 5 or negative 5 times a plus 5. Negative 5a minus 25. Negative 5a minus 25. Subtract that quantity from what's up above. Change it to addition of the opposite. Add up the terms, like terms. Negative 5a plus 5a is 0. Negative 25 plus 25 is 0. So the answer, a minus 5. So again, we create a column for a missing power of the variable so that things line up nicely. Any questions on this particular example? Okay, let's go back and look at some more examples. Let's see here. 25x squared minus 16 divided by 5x minus 4. So the divisor, 5x minus 4, goes outside. The dividend goes inside. 25x squared. Oh, but we're missing the powers of x, so plus 0x minus 16. So I've got x squared, x, no x at all in my columns. Now I'm going to take the leading term inside divided by the leading term outside. 25x squared divided by 5x is 5x, which goes in the x column. Then we take 5x times the divisor, 5x minus 4. We get 25x squared minus 20x. So 25x squared minus 20x. We're going to subtract that quantity from what's up above. We'll distribute the subtraction sign or change it to addition of the opposite. Adding up the columns, 25x squared plus negative 25x squared, excuse me, is 0. 0x plus 20x is 20x. Bring down the next term, start the process all over again. Leading term inside divided by leading term outside. 20x divided by 5x is 4, so plus 4. 4 times 5x minus 4 is 20x minus 16. 20x minus 16. Draw a line, subtract that quantity from what's up above, change it to addition of the opposite. Add up the columns, 20x plus negative 20x is 0, negative 16 plus positive 16 is 0. So our final answer is 5x plus 4. Okay, let's see here. Trying to find some missing terms. I know I had some here that were a little bit different. Here we go. Sorry. Y cubed plus 8 divided by y plus 2. All right. So the divisor goes outside, y plus 2. The dividend goes inside, y cubed plus 0y squared plus 0y plus 8. So my highest power of the variable y is y cubed. So I need to have a y cubed column, a y squared column, a y to the first power column, and a constant column. So I needed to fill in 2 missing columns with 0 coefficients. All right. So now leading term inside divided by leading term outside. Y cubed divided by y is y squared. So that goes up here. Then we're going to take the y squared times the divisor, y plus 2. And we get y cubed plus 2y squared, which goes up here, y cubed plus 2y squared. We're going to subtract that quantity from what's up above. We'll change it to addition of the opposite. Y cubed plus negative y cubed is 0. 0y squared plus negative 2y squared is negative 2y squared. Bring down the next term, which is 0y. Start the process over. Divide the leading term inside by the leading term outside. Negative 2y squared divided by y is negative 2y. So minus 2y goes there. Then we take negative 2y times y plus 2. We get negative 2y squared minus 4y, which goes up here. Negative 2y squared minus 4y. Draw a line, subtract that quantity from what's up above. Change it to addition of the opposite. Negative 2y squared plus positive 2y squared is 0y squared. 0y plus 4y is 4y. Bring down the next term. Start the process over. Leading term inside divided by leading term outside. 4y divided by y is 4, so plus 4. 4 times y plus 2 is 4y plus 8. Put that over here underneath there. Subtract that quantity from what's up above. Change it to addition of the opposite. 4y plus negative 4y is 0. 8 plus negative 8 is 0. So no remainder, and this is our final answer. Y squared minus 2y plus 4. Any questions about that one? Okay, let's see here. How about this one? A cubed plus a divided by a plus 3. So on the inside, we have a plus 3, excuse me, on the outside, the divisor is a plus 3. On the inside, I've got a cubed plus 0a squared plus a, and then plus 0 as our constant. I may or may not need that 0 for the constant term, but I'm going to put it there. We'll see what happens. Okay, so leading term inside divided by leading term outside. A cubed divided by a is a squared, so that goes in the a squared column. A squared times a plus 3 becomes a cubed plus 3a squared. So a cubed plus 3a squared. We're going to draw a line, subtract that quantity from what's up above, but change it to addition of the opposite. Here, let's get rid of that mess. Okay, so a cubed plus negative a cubed is 0. 0a squared plus negative 3a squared. Here, put that up here, is negative 3a squared. Bring down the next term, plus a. Start the process over. Leading term inside divided by leading term outside. So negative 3a squared divided by a is negative 3a. So minus 3a goes up there. Negative 3a divided by a is negative 3. So minus 3 goes up there. Okay, let's see here. Hang on a second here. Something does not agree with me here. So let me see if I've made a mistake. Hang on. I'm going to pause the and we're back. I couldn't find any mistakes. We'll continue. Let's see what we've got here. So minus 3 or negative 3 times a plus 3. Oh,
Mr. Mayo.
Yes.
Oh, did you put so below at the very bottom, shouldn't it be negative 3a squared below that, and then it should be the a
yeah,
I missed that part.
Thank you. I was waiting for somebody to figure out what I'd done wrong. So let's back up a little bit here. Let's see if I can figure this out. Okay, I'm going to start over. Okay, yeah, I knew there was something wrong, but I couldn't see what it was. All right, so watch carefully this time. Here we go. So I take the leading term inside divided by the leading term outside, right? So that's a cubed divided by a, which is a squared. So that goes there. Okay. Then I take a squared times a plus 3, which is a cubed plus 3a squared. So a cubed plus 3a squared. Subtract that quantity from what's up above, change it to addition of the opposite. A cubed plus negative a cubed is 0. 0a squared plus negative 3a squared is negative 3a squared. Bring down the next term. So far, so good? Okay. leading term inside divided by leading term outside. Negative 3a squared divided by a is negative 3a, which goes there. Okay. All right. Negative 3a times a plus 3 is negative 3a squared minus 9a. Here we go. Minus 3a squared minus 9a. So we're going to subtract that quantity from what's up above, change it to addition of the opposite. We get 0a squared plus 10a. And there we go, plus 0. Okay, so 10a divided by a, 10a divided by a is 10, so plus 10. And we get 10 times a plus 3, 10a plus 30, 10a plus 30. Subtract that from what's up above, change it to addition of the opposite. 10a plus negative 10a is 0, 0 plus negative 30 is negative 30. So my answer is a squared minus 3a plus 10 plus negative 30 over a plus 3. Okay, thank you for helping me find my mistake. It's always easier for somebody else looking at your work to see what you did wrong. Okay, any questions about that one? Let's see here. How about this one? 5x to the fourth minus 10x divided by 25x cubed. Now, wait a minute. This is a polynomial divided by a monomial. So this goes back to what we did yesterday. So we don't do this problem the way we've been doing the ones here recently. We take each term in the numerator and divide it by the term that's in the denominator. All right. Then we go back and reduce each fraction separately. 5 over 25 is 1 over 5. X to the fourth over x cubed would be x to the 1. So I have what? X over 5. And then minus 10 over 25 is 2/5. X over x cubed is x to the 1 minus 3. So this would be what? Minus 2x to the negative 2 over 5, which would then be, let's see here. I've got too many minus signs there because I already used it. Okay, so this would be what? 2 over 5, but then this becomes x squared in the denominator. Okay, with that, you could also write this term like this, 1/5 x and then minus 2 over 5x squared, either way, because there's an implied 1 in the numerator. All right. Let's see, what about this one? 112 u z to the fourth over negative 42 u cubed z to the 8th. So 112 over negative 42 would be negative 3, okay, because this would reduce down to negative 3 over 1. All right. U over u cubed. U over u cubed is like u to the 1 power over u cubed, which is like u to the 1 minus 3 power, which is u to the negative 2 power, which is 1 over u squared. Okay. Z to the fourth over z to the 8th. Z to the fourth divided by z to the 8th is z to the 4 minus 8, which is z to the negative 4, which is 1 over z to the fourth. So this becomes what? Negative 3 over u squared z to the 4th power. So there's your final answer, just looking at it like factor by like factor. Any questions there? Okay, let's see here. How about this one? 2x plus 3 divided into 7x squared minus 3 plus 4x plus 2x cubed. So on the outside, we've got 2x plus 3. On the inside, we don't have any missing powers, but it's not in descending powers. So 2x cubed plus 7x squared plus 4x minus 3. And now we're ready to get going. Leading term inside divided by leading term outside. 2x cubed divided by 2x is x squared. X squared times 2x plus 3, 2x cubed plus 3x squared, 2x cubed plus 3x squared. Subtract that quantity from what's up above, change it to addition of the opposite, add up the columns. 2x cubed plus negative 2x cubed is 0. 7x squared plus negative 3x squared is 4x squared. Bring down the next term and continue the process. Leading term inside divided by leading term outside. 4x squared divided by 2x is 2x. Write that up here in the x column. 2x times the divisor, 2x plus 3 is 4x squared plus 6x. 4x squared plus 6x. Subtract that from what's up above, change it to addition of the opposite. 4x squared plus negative 4x squared is 0. 4x plus negative 6x is negative 2x. Bring down the next term. Divide the leading term inside by the leading term outside. Negative 2x divided by 2x is negative 1. So we get negative 1 times 2x plus 3, negative 2x minus 3. Subtract that from what's up above. Change it to addition of the opposite. Add them up. Negative 2x plus 2x is 0. Negative 3 plus 3 is 0. So that's our final answer. Okay. Now, if you think about it, these columns, let's see, this is like what? The cubed, square, first degree, constant term, 0 degree. Okay. If we think of a number like 4,738, okay, this is the ones column, so that would be 10 to the 0 power. This is the tens column, 10 to the 1 power. This is the hundreds column, 10 squared, thousands column, 10 cubed. So what I'm getting at is these are in powers of 10, and we put zeros in for the missing powers, just like these are in powers of whatever variable there is. All right. Well, that's all I've got for you for today. I will be back at 1:15 with an office hour. Tomorrow, we will meet and review. Tonight's homework is to wrap up section 5.8, part 2, as well as the chapter review material. So I'm going to go ahead and stop the recording.